All right, let's talk about something we all rely on but rarely think about. We live in a world that absolutely runs on invisible data, right? But what happens when that data gets corrupted? Today, we're going to dive into the pretty shadowy world of GPS interference. We'll break down the difference between the brute force of jamming and the really clever deception of spoofing. These are two threats that every single RF professional out there needs to understand inside and out.
Okay, before we get into the weeds, we've got to cover a crucial notice. This is part 5 of a big 20-part tutorial, and it's all based on a comprehensive report called An Introduction to Radio Jamming and How to Identify by RFI Detectives, who are a part of Virtualization Options LLC. Now, this is purely for educational and interference mitigation purposes, and I have to stress this. Using radio jamming equipment is illegal in most places around the world, and the penalties can be really significant. Our whole goal here is to help you, the RF technicians, get better at identifying, locating, and reporting these illegal signals.
So let's kick things off with a simple, but honestly, a pretty unsettling question. Think about it. From global shipping and the financial markets all the way down to the phone that's in your pocket, our entire modern world runs on the super precise timing and location data from GPS. But what happens when that system, well, what happens when it lies? That's the world we're stepping into.
When we talk about attacks on GPS, they really come in two main flavors. The easiest way to think about it is like the difference between a sledgehammer and a scalpel. Say, one is all about brute force denial, just smashing the signal. The other is about sophisticated deception, subtly changing it. And understanding that difference, that's absolutely key.
This slide right here, this really gets to the heart of it. Jamming, that's your sledgehammer. It's a blunt instrument. Its only goal is denial of service. You just blast so much RF noise that the incredibly faint DPS signal gets completely drowned out. It's loud, it's messy, it's obvious. But spoofing, spoofing is the scalpel. Its goal is way more sinister, deception. It doesn't just block the signal, it carefully crafts a fake one to trick a receiver, basically hijacking its entire perception of reality.
Let's zoom in on spoofing, because it's the more complex threat. We're not just talking about blocking a signal here, we're talking about replacing it. Just imagine creating a counterfeit satellite broadcast that is so perfect, a receiver doesn't just lose its lock. No, it confidently locks onto your lie. It starts calculating a position and a time that you, the attacker, are feeding it.
So how in the world is this actually done? Right? How does an attacker build an entirely false reality for a GPS receiver? Well, it's not easy. It's this complex, multi-step dance of digital mimicry, and it takes some serious technical skill. So let's break down how it actually works.
Okay, so here's the spoofer's playbook. Step 1, synthesize. They have to create a fake GPS signal from absolute scratch. Step 2, imitate. This fake signal has to include the correct pseudo-random noise codes, the PRN codes, which are kind of like the unique digital fingerprints for every satellite up there. Step 3, mimic motion. Now, to be believable, the fake satellites have to look like they're moving across the sky. The spoofer does this by adding plausible Doppler shifts to their signal. Step 4, inject the lie. This is the moment. This is where the manipulated navigation data, the false location and time, gets embedded. And finally, step 5, capture. The spoofer cranks up the power on their signal just enough to overwhelm the real, much weaker satellite signals, forcing the receiver's tracking loops to let go of the truth and lock on to their counterfeit reality.
Now, what's really fascinating here is that this shows a specific, high-stakes target, the L5 band. This is a safety-of-life signal, mainly used in aviation. It's designed to be more powerful, more robust. But guess what? Because it's so important, it's becoming a really attractive target for these sophisticated spoofing attacks. This isn't just theory. We're talking about real-world consequences for critical infrastructure.
And this vulnerability, in a critical system like aviation's L5 band, that is precisely why we as RF technicians have to be so sharp about telling the difference between a jammer and a spoofer. Because how you detect the problem and how you fix it are completely, totally different depending on which type of attack you're actually facing. So here's the bottom line. Jamming is usually a big, loud, obvious spike of noise on your spectrum analyzer. It's like a giant haystack that completely buries the tiny needle you're looking for. It's a denial of service you can often see pretty easily. But spoofing is a subtle deception. The fake signal might look totally legitimate at first glance, hiding in plain sight. It takes much more sophisticated signal analysis to peel back the layers and find the manipulation. Your entire mitigation strategy hinges on making the right diagnosis out in the field.
And that really gets to the heart of what you do. Being able to look at the RF environment,
and tell the difference between some accidental, unintentional noise and a deliberate, purposeful attack, whether that's jamming or spoofing. That is one of the most critical skills you can possibly have. It's the foundation for everything else we do in interference hunting.
So we'll end with this thought. The more our automated, interconnected world, I'm talking stock market trades timed to the nanosecond, autonomous vehicles navigating our streets, the more all of that depends on these invisible GPS signals, the higher the stakes become. As the front line of defense, your work isn't just about fixing a technical problem anymore. It's about a much bigger question. How do we protect the very truth of the signal itself?